this microphone's working great. So look, thanks very much for having us along to the AWS meetup here in London. It's great to be talking to you. So tonight we're talking about how we find the signal in the noise, essentially. So how do we take a vast amount of our clients' data, often mainly unstructured data, so things like audio, documents, and video, and look for risks and issues in that. So leveraging the elastic scalability of AWS, but also open source technology and some of our own technology. So hopefully you're going to find this quite interesting. So let's first start by introducing ourselves. So my name's Oliver. I lead the architecture function in a part of Deloitte called Risk Advisory. Talk a bit more about risk advisory in a minute. My role is to act as the translator between some really smart people who work with clients, advising clients on risk, unsurprisingly. Kind of name says what it does. And the possibility of modern technologies like cloud, Internet of Things, blockchain, and various other things, and look at building innovative products. So, like Laura was saying, we're not just a consultancy that puts people into clients. We also are building technology solutions that sometimes go hand in hand with that consulting work, but other times are just standalone software as a service type services that people can sign up for. As you can see, I'm slightly AWS certified, as in I'm a cloud practitioner, just to kind of have a broad awareness. My colleague Allan, who will introduce himself, is the guy with all the certifications, it seems, at the moment. Anyway, Allan, I'll let you introduce yourself.
Evening all. Hi, I'm Allan Smeyatsky. I'm a solution architect working for Deloitte for a couple of years. I come from a long multi-year legacy background, but more recently in the last couple of years I've become cloud certified in all three major platforms. But most of the work I do is done on AWS.
Thanks, Allan. So let me just set a bit of the scene of where we sit in amongst wider Deloitte. So Deloitte is a massive global organization. I think there's about 370,000 people globally, right? So it's a huge organization. And within the UK and Europe, there are a number of parts of Deloitte. And I just wanted to kind of call out where we sit and where other parts of Deloitte are that are using AWS. So Allan and I sit in the risk and advisory part of the business, but there's also financial advisory who do a similar thing to us, but advising kind of the financial departments within firms. You've got the audit business that most people know us for, big audit firm, big audit practice, but it only accounts for a fraction of what we do now. A massive consulting practice, and Laura and others here tonight are from that area of the business who deliver consulting services on how to get the best out of cloud into clients, and then our internal IT team as well, are big AWS users as well. So if you move on, Allan. This is the only sales slide, and actually it's not one of my slides, so I won't be spending very long on it. There are other people in the room who can probably do a better job of this, but essentially, look, we as much as Allan and I are going to talk about how we're using cloud to build products and software as a service platforms, we also help clients on the cloud journey, right? Everything from planning all the way through to operations and delivery and so on and so forth. But if that's of interest, then by all means grab Laura or someone else later on. So look, let's get into the meat of this then. So risk advisory, what is it? What is it about, and what are the big problems we're trying to solve, right? So a lot of this is essentially, as I was saying earlier, it's taking really smart people that work with clients that help them solve risk challenges. And risk challenges, by the way, can be everything from the sort of risks that we probably all know from technology projects, those that you're working on technology projects, so things like delivery risks, right? So will the project get delivered on time, to the right cost, quality, et cetera, et cetera. So that's the kind of operational risk area. But there is a whole bunch of other risk domains. So there's credit risk, there's financial risk, there's cyber risk. We cover pretty much all of it. What we're going to talk about tonight is mainly the regulatory risk side of things. So particularly the banks. They've got a lot of regulations. You've probably heard quite a bit about them in the news, particularly when banks get it wrong, they get heavily fined. What we're trying to do is either help banks that have identified that they have a problem, so perhaps they've been found mis-selling a product, financial product, or they want to make sure they're compliant. There's a few ways of doing that. They can either employ armies of people to go and do compliance, or the new wave is something many of you probably have heard of, which is RegTech. So how do you employ technology to help you with regulatory compliance? So how do you use AI and the cloud and various other technologies to make that simple and make that easy? So what we're doing is, as I say, we're working with some smart folks who have come up with kind of risk calculators, risk engines, and then also working with our data science colleagues. So one thing I should say is that neither Allan and I or I are data scientists, right? So don't ask us any big data science questions. But what we have worked with the data science team to do is take their clever algorithms, their machine learning models, and scale them. So So yeah, if we move on. So what we've done, essentially we've identified that we could solve this problem time and time and time again, or we could build an enabling platform. So what we have here in the middle is that stuff I was talking about. It's that the algorithms, it's the machine learning models, it's the risk engines, and so on. How do we wrap that with a platform that secures that can scale it, that can offer it as a service, in a business that, let's face it, until fairly recently, last few years, has been about delivering people services, not about delivering technology services. How do we deliver this really robust technology service that complements our people services? So what we have on the right is the kind of level of architecture that sadly these days I get to, which tends to be PowerPoint architecture, I must confess. You've got Allan here who actually knows this stuff when it comes to AWS. What we essentially have is an API platform, right, where you have the ability for API requests to come in from clients or from our products, so our user interfaces that we build for clients, to come into an orchestration platform, orchestration layer, deals with security, deals with load balancing, and so on and so forth. One thing I should say about this platform is we try and make it as asynchronous as possible, right? So we try and promote this approach where you put in a request, we do some clever processing, we scale up that processing, which I'll touch on in a minute, and then we'll return a response. Rather than the synchronous pattern where you kind of put in a request and get a response back directly.
Although we do that as well.
We do that as well, but I guess the point here is that where we've scaled machine learning and data science most effectively is where we've decoupled that, right? Or we've made it asynchronous. So what we have is a bunch of queues. We then have a whole load of workers, which we'll elaborate on in a minute, which then scale up and scale down depending on how much has come into those different queues. Those workers will then post to output queues. Those output queues are sometimes used and chained into more workers, so we have like complex execution flows, and then we pass that data back. Generally, data comes in on S3 and an API call, and generally we'll then post data back, responses back through S3 or API calls as well. So we move on. So this breaks down into, it's an API platform, so we're using a lot of API management from AWS, we'll elaborate on in a minute. We've got licensing, so to secure who can access what services. We can configure and orchestrate different workflows, so each of the workers can be linked in different ways to create different workflows. And then the core of the solution are these workers, right? So that's where we've taken certain types of machine learning models or different technology components and broken those down into microservices, and then built a set of workers that can scale up and scale down. And then the last point on this one is billing. So we want to offer a really flexible billing structure, like a pay-as-you-go type model. So you can think of this a bit like a mobile phone subscription. So yes, there's some flat fees, but actually a lot of this is how much you use it. It's based on consumption, right? So if you send in thousands of hours of audio, we're going to charge you based on the amount of hours of audio. Or if it's documents, it might be based on the megabytes size of the documents. So we've got real flexibility about how we bill, and to do that, we have to capture a whole load of stuff that's going on behind the scenes, right? We need to calculate our costs of running the AWS platform and then work out how much we charge for each of those calls. Move on. So Allan, I think it's a good point now to actually talk a bit more about what we're doing with this platform, right? What are the problems we're solving? What are these workers? What do they do?
Thanks, Oliver. So as you already mentioned, we have several workers that we use throughout the solution. So ones to call out, for example, Orchestrator. This is a prime worker. The orchestrator is used to configure. It's the first worker that's invoked, and basically all workflows will be run by the orchestrator. Two other key ones to talk about are transcription and OCR. We call these commodity workers. So what the transcription worker does is that basically takes any audio or video file of any format actually, and it will run it through the transcription worker and will return text. What we then do with that text is we then run it through subsequent workers, which will then allow us to add machine learning on top of that. And why we call it a commodity worker is because we can use it in a workflow, like a call center workflow, which will then, after doing the transcription, we'll run it through some machine learning to give additional insights into what's been said in that call. Similarly for OCR, the OCR worker does optical character recognition. So what that allows us to do is we can feed it in PDF documents, and based on that, we can get XLS out of that or other formats as well, and again, then run that through the machine learning. So where the magic happens are these two here, feature extraction and scoring. It's our ML framework, machine learning framework, and once we've taken the various attachments, run it through there, then we will push it through feature extraction or scoring, and that will then return the insights as mentioned. We have an antivirus worker, so every single workflow will have basically we'll check the input file to see that there's no malware attached to it, and we can also invoke that in a synchronous fashion to just, if somebody wants to just have a REST call to an antivirus worker on...
And Alan, that's a good example of one where we've had to build something to complement AWS, right? So one of the things our security team called out was, how are you antivirus checking anything on S3? And we're like, well, AWS doesn't have antivirus feature yet. It may well be in their roadmap, don't know. But so that was one of the things we needed to build in response to client compliance requirements and our own compliance requirements.
Thank you, Oliver. So a couple more. So external API worker, what we found out is with some of our projects, whilst we could build something and build a worker for each and every bit of capability that a client wanted or a project wanted, in fact, there were certain public APIs available that were much easier to use those. So what we've built is we've built this external API worker that will allow us, for example, go out to Google, get some information and return to the workflow and continue. The final worker worthwhile talking about is probably callback. When we've been through an asynchronous workflow, what will happen is we will then post the response back to an S3 bucket external to the solution, which we'll see in shortly.
So the API for this, actually, so one of the things I've done in my career is do a lot of API platforms. When I was at 3, I was responsible for building the API platform at 3 Mobile. And for those of you in the room who've worked with API platforms, I'm sure it will resonate with you the fact that versioning them and managing the different API instances and stuff is an absolute nightmare. So actually what we've managed to do here is create quite a beautifully simple API which relies on kind of parameters to request the types of workers or workflows that are requested. So rather than us having methods for each of the different workers and workflows in the solution, actually we've got a really simple kind of job-based API, which then allows you to kind of request through parameters and through what you send in, the requests you send in, to kind of then get the processing you want, which has been brilliant because it's allowed stability of the sort of interface layer, and it's made it really easy to build against this platform.
And easy to onboard clients.
Yeah, absolutely.
So yeah, basically just a quick run through of the APIs. We've got an upload destination. So what that'll do is it'll allow us a client to post a audio, video, or text document to an S3 bucket, and they'll get a time-limited URL back from S3, which is then used in the subsequent the post job, sending in the URL as a parameter. And obviously, it'll also send in the workflow because there's multiple workflows for all the different clients. It'll immediately get a job ID back. Then that job ID will, dependent on the type of workflow, it might just continue through to callback and post the response back, or you could actually poll for the response using the job get. So you could just poll for using the job ID. And finally, we've got immediate tasks. So some of our clients had aggressive non-functionals, and we were concerned about leaving it in a queue in an asynchronous fashion. So we've developed this synchronous mode, and that will, as quick as the worker can return, it will immediately return the response.
So this next bit is the bit that I'm sure you all want to hear, which I'll hand over to Allan and allow you to do, which is what is the meat of this. And unfortunately, we can't go into all the ins and outs because some of this is a little bit of our secret sauce. But you know, the AWS stuff, absolutely, we can, and some of the custom things we've built, we can absolutely talk about. So Allan, let's walk through what the AWS flow looks like for this.
Sure. So basically, we've got our subscription clients here, which can be either an application or actually a client using the API itself. They'll come through into the web application firewall for some additional security, and they'll hit the API gateway. At the API gateway, we've got a Lambda, which is an authorizer Lambda that will query DynamoDB, and we will allow or disallow the client into the solution. They're obviously protected via API key and API secret. Once the client is allowed into the solution, the first thing they'll do is they will go into NLB, the network load balancer, and they'll hit the orchestrator. Now, as you've seen on the previous slide, we've got multiple workers. There's 10 or 12 workers here, and we're onboarding about 4 or 5 other projects at the moment, and each of them have between 3 to 5 workers. So this is going to carry on growing quite substantially. But in effect, what happens is the orchestrator will go to the workflow, and it will retrieve the configuration that it's needed. And what it can then do, it will then invoke one or many workers. So as an example, it might use worker 1, worker 3, and worker 5. And it will then basically, each worker will run, which is basically a Docker file with the application all written in Python, and it runs on ECS. this is just a replication of all the workers that we've just seen earlier. We will then hit the callback worker at the end of the flow, and we will then post the response back to an external S3. What else have we done in the solution? Every single worker issues events at start of event, at end of event. That is drained into SQS, and there's a Lambda that will route that into the billing events to ensure that we don't lose a single billing event. And we are integrating that off to a billing solution as we speak. We have built a customer management platform in Angular, which allows us to control the configuration updates into the solution in a controlled fashion. And we've got a bunch of S3 buckets. So the S3 buckets are used as I mentioned earlier, with upload destination. When you put the file into the solution, the workflow runs, you retrieve it and you put it into the working bucket, and there's multiple other buckets there. As an example, for the machine learning, we have a machine learning bucket, so we can have multiple models that can run on there for the feature extraction and scoring. So the magic of this is our lambdas for auto scaling. So the solution is written. All of the workers are written in Python under the Celery framework. We use Redis for in-memory cache. But what this Lambda does is this will query CloudWatch metrics, and it will look at the queue size. It's not like the standard auto-scaling and auto-scaling groups that use CPU and memory. What it does is it actually looks at the queue size. So when we have multiple queues, multiple interactions coming into each particular queue, we will scale up the EC2 and the ECS accordingly. As an example, for transcription worker, we've had 800,000 files, audio files of varying lengths, and we've processed that in 48 hours. And we had about 200 EC2 that spun up for that. When the workers are configured, we deem how many tasks can sit on each EC2, and then we know when to scale up.
Should we bring this to life with an example? You touched on the audio files.
Yeah,
right?
Sure.
So you have an audio file, well, a bunch of audio files essentially hitting this solution, right, being uploaded either directly by a client or one of our products kind of managing that as a front end. Those are going in, they're getting loaded to S3, we're then requesting processing. And that processing could be, let's say, detect risks in a phone call, right? So perhaps it's a phone call between a salesperson and a customer. Why are the risks in that call? So as Allan says, there's the transcription piece, which will give us the text of that call, so we can do some sort of fairly commodity type stuff like checking for keywords. But then that gets fed into a bunch of machine learning models, as does the audio file itself. So the actual shape, the audio of the call also gets passed into a machine learning framework, which is looking for risky calls based on tone or based on how aggressive someone is being on a call, or various other things.
And we didn't touch upon those because that's audio and text worker that does that kind of pre-processing to get to that. Yep. And then there can be dictionaries on the as well, which will for specific words.
But just to bring it to life with a real life example, right? So this is where this gets clever. Is imagine you're a large financial institution that's got masses and masses of calls that you need to look back through to check for mis-selling. Well, you can either do that with throwing lots of people at the problem, or with this platform, we've successfully done that by essentially chucking the elasticity of AWS at this problem and our clever data science algorithms over the top. So this thing has scaled right up, and we've called it infinity now because essentially we can and we have exhausted certain types of instances in AWS regions, right? So the new M5 instance where it first came.
Yeah, but that was because it was brand new.
Well, it was very brand new, right?
We'll touch upon that.
But in theory, this thing can scale up until the limits of AWS. We'd be running up a massive charge at that, some serious charges at that point. But that's the reason why it's called that, right? Is that we have that flexibility. Okay, so let's have a bit of a recap then on what AWS services we're using, and also where we've had to go custom. Where have we had to build custom solutions? So we touched on some of the custom solutions already, but we'll talk about a couple of new ones maybe. So Allan, do you want to just kind of recap perhaps what we've
Certainly. So all of the workers are housed in Docker files, and they are in ECS at the moment. We've obviously got Lambda functions, which are used throughout the solution for auto-scaling and for the Lambda authorizer and for billing. We're using SQS to drain interactions successfully into either DynamoDB or externally. One thing we didn't talk about is CloudFormation. All of the solution is written in CloudFormation infrastructure as code. We have about 9 stacks, and it takes approximately, it's down to about 2 hours now. It was at a day. It's about 2 hours to deploy a new instance, and we'll be touching upon environments shortly, but we've actually deployed in globally as well, and we're going to be deploying in other regions too. And it's about a couple of hours to deploy everything with the CloudFormation stacks, which are all nested. We use a lot of S3, as we spoke about earlier, for the audio files and for configurations. We're clearly using, from the network, we're clearly using the API gateway. It's the only point, it's the way into the solution. We've got CloudWatch monitoring throughout the entire solution, and the metrics are used as well for auto-scaling. We've got application load balancers and network load balancers. We're in 3 availability zones in London at the moment. And we've got, it's a stateless solution in a private VPC. We're using DynamoDB NoSQL for the configuration and for billing and for various other things.
And that's a really
There's no RDS in the solution.
Yeah, that's a really key thing, right, is that we needed a NoSQL type database to give us the scalability, because we could be spinning up thousands upon thousands of workers. Originally, some of the data scientists actually wanted to use traditional database technology, and the problem was we literally could not scale an RDS instance big enough to accommodate the output of this solution. So we had to say no more transactional sort of relational databases.
We even had a worker which we deprecated, in fact.
Yeah. So DynamoDB is really important, as is SQS and those things that can handle that traffic.
That's really good for, as you all know, it's really good for fast writes and not really good for reading.
Yeah.
And finally, we've got Redis in memory cache. So things we needed to build to complement the AWS services. So we obviously built the orchestrator and queue-based auto-scaling solution, which we've spoken about before, which seems to work very well. But in addition to scaling up, we needed to scale down, because that was also key. So scaling up is very important, as you can imagine, but if you don't scale down to 0, you then incur massive costs. So we deployed the poison pill pattern, which allows us to kill off superfluous workers when they're not needed, and we can scale down completely to 0. Very important, we've built a Python worker framework. So as Oliver's already mentioned, we've got quite a few data science teams and in risk advisory who have built a lot of applications which are kind of used in a legacy fashion. So now, in order for them to be able to onboard onto Infinity, they have to be given guidance as to how they can do that. So we've built this Python worker framework, which allows us to work with data scientists and basically take their code, refactor their code, and make it fit for purpose for Infinity as a worker.
But the goal is that that's as uninvasive as possible, right? That we can largely take a data scientist's code, do not an awful lot to it, and then get it on this platform very quickly.
Yeah, and to get them not working on their local machines, obviously.
Yeah.
And then antivirus scanning for S3, which we spoke about earlier, we've got that in a synchronous and an asynchronous pattern.
So perhaps just quickly talk about
I'm not conscious of time. So continuous integration and deployment. We've got 4 main environments: dev, test, UAT, and sorry about that, production, as you can imagine. And when the code is pushed into GitLab, there's a Jenkins job that'll push it into the dev environments. There's additional Jenkins jobs that'll push it into test. We then do manual testing and automated testing. From there, once that's fit for purpose and good to go, we'll go into UAT to allow our customers to do their user acceptance testing, and then it'll go into production where it sits. Obviously, we have a management VPC, which is the top portion here, and that's where Jenkins, GitLab, and ECR sits. Just some of our tools. Obviously, we're using Python. We use the Celery framework. We're using Angular in the front end. Now, we also we work in a completely agile fashion, and everything's done using Jira. So we run two weekly sprints. And tickets get raised, and we basically have various teams and third parties that assist us to carry on doing all the great work we're doing on Infinity. We also use Confluence for documentation, and recently we've just started using the Sphinx plugin for the Python workers. So what that does is it'll auto-generate documentation in Confluence for us. So there's continuity between the Python, the data science teams.
Great stuff. So look, let's wrap up. So what have we learned? We've learned a massive amount about AWS, particularly moving from infrastructure as a service, right? So moving from sort of standard regular EC2 into the serverless world, into the kind of infrastructure as code. So very much moving our capability from running workloads on virtual machines in AWS into this kind of brave new world of serverless and highly scalable cloud services, highly elastically scalable cloud services. So the other thing is, we've kind of learned where the limits are, right? So originally I was sort of saying, well, why can't we use Lambda for some of these workers? And then we sort of said, well, no, that's not going to work when we've got really chunky processing to do because we're going to time out a Lambda. So it was kind of working out where some of these things fitted in as perhaps ancillary tools to the kind of core stuff that's still sitting on ECS and EC2. We had to collaborate really closely with the data scientists, right? And that can be a challenge because the data scientists just want to kind of, they just want to crack on and get their kind of algorithms built. But it's kind of finding the right balance of giving them sort of enabling platforms without constraining them too much. So that's always a kind of an ongoing juggling act with them. Cost optimization is a big thing for us. So originally, a lot of this was being spun up just quick and dirty on demand, and it was costing us a lot of money. So on demand instances, we managed to save significant amounts of money by intelligently using Spot and reserved instances.
And I think the call out there is that with Spot, don't go for the latest generation, because if you go for the latest generation, everybody wants that, and then you're most likely not going to get that, and your instance might be reclaimed. So the main takeaway with that is always go for second generation kit, which is usually fine, and using a combination of Spot and reserved, may save a lot of money.
But I guess the synchronous pattern works very well for us there, right? Because if a worker gets killed, it doesn't matter because we've not got a hard return deadline. With our real-time services, we've had to use reserved instances, right? So Spot works really well for our scale up, scale down asynchronous workloads, but it's not really suitable for synchronous requests. So, Allan, clearly the AWS moves really fast, right? And we've seen lots of developments over the last sort of year, 18 months since we started this work.
Absolutely. I mean, at reInvent every year there are hundreds of very many new services that are announced and released, and I think the main point is to really just keep up with all of the blogs and looking into all of that and understanding when the services do change. Now, what could have happened is, you quite easily could have developed a custom solution, which is costing a lot of money, and you're probably feeling a lot of pain from it still. So have a look to see, does a managed service come out there which actually is better to use, and then, look to reevaluate quickly, I think. A good example is SageMaker and Fargate, actually, two great examples that we can talk through. So whilst we have an ML framework deployed on Infinity, at the same time, SageMaker's moved on quite significantly, and it can host quite a few frameworks at one time. So what we're doing is we've got two of our main data science teams that are working with training models in SageMaker in some AWS accounts, and we are now looking at actually can we suspend execution of a workflow in Infinity, go off to SageMaker, run a hosted production model, and then go back to Infinity with a workflow. This is stuff that's happening now. When Fargate was first announced 18 months ago, we looked at that then, and we thought, do we need to move to it straight away? But the cost actually didn't match up. Costs have subsequently dropped by half, so it's suddenly on the cards again, and we are investigating Fargate further to see if there's any sense in us moving from our standard ECS onto Fargate as we speak.
Yeah. And then what's next? So this has been highly successful. This has allowed us to do really innovative things for clients that our competitors haven't been able to do. So we've learned a lot along the way. I'll put my teeth back in. And we think the concept can be expanded to two other key areas of what we do. One is collecting data from clients and third parties. So how can we create a highly scalable platform that manages that data ingestion, management, ETL, etc., secure storage of data. Security, one of the things we haven't touched on massively through this talk, but securing S3 through encryption and various other things. So that's one thing we are actively working on at the moment. The other thing is taking the same sort of concepts but to the user experience, so the user interface layer, so our products that clients see and touch and use. So moving on from sort of Angular and Django, which has been our stack, into things like GraphQL and AWS AppSync and so on. So we've got a project at the moment that's spiking into using that and making a more configurable, modular approach to building our products. So rather than coding everything from scratch, how can we have a component library essentially of UI widgets that we can build from and leverage?
Quite exciting, actually.
Yeah, no, it is. It's a leading edge stuff.
Serverless front end.
Yeah. And then, as Allan said, we're looking at SageMaker very actively. We're also looking at where AWS Batch and where AWS Step functions kind of fit into the picture as well. So it's really exciting. So look, I hope that's been interesting and enlightening. It's very different from perhaps the perception you might have had of Deloitte before we perhaps spoke to you. We're very much doing technology. We're not just talking about it.
Yeah.
We are very much living and breathing this stuff and learning along the way. So it's been great to talk to you. And
thanks very much.
Yeah, thanks. Yeah, sure.
Do you have any questions? All right, we'll take two because And Martin, you're not allowed because you're speaking.
I'm Martin's colleague, so I hope I'm allowed.
Very good. Delegate.
I obviously had quite a cool and complex diagram before, and I noticed Dynamo, and then you also mentioned that you used Dynamo for the scaling part. Was that for capturing events?
Absolutely, yeah.
Okay.
So it's the event-driven kind of approach, right?
So it's more of a two-part question
yeah.
then. So based on that, were you also have you considered any other means of capturing events? I'm imagining you then have to access the events through your EMR and so on. Have you considered perhaps putting it in a data lake or Kafka or something like that?
That's probably an add-on. I mean, the main reason we're capturing the events was A, for billing, and B, for kind of like diagnostics, fault finding, like what happened with a certain sequence of workers firing, why didn't something quite work as expected. So what we're looking at doing now is building a Lambda that sits off the back of the Dynamo that then does something else with that event. So maybe pushes it into, as Allan was talking about, our billing solution, which then will generate bills and invoices off of.
But we're also looking into Elk at the moment, Elasticache, Logstash, and Kibana for some enhanced log monitoring. Or we may use the AWS service, which is kind of actually also got Elasticsearch in it. But the preference is Elk, I think.
Cool. Unless you're Martin's colleague, I'll have time for another question. I think there was one over there.
So that basically the Jenkins jobs can get to it, and it can then push it to all the various environments for as we do deployments.
So why not have CI repository for every environment?
Well, because it's the same Docker image that gets moved between environments. So dev and test is a smaller environment, but UAT and production are the largest. But it's the exact same Docker images that get moved from ECR into each environment.
Bear in mind those environments as well are very dynamic, right? We can spin up specific environments for a project or for a particular service if we need to, or in a particular region. So some of the things we have is processing can only happen in the UK, or only happen in a certain country, or the US, or whatever. This flexibility of having all the scripts in CloudFormation with Jenkins allows us to build all of that anywhere. So
No, I mean, we could have ECR in each separate account, but that would just involve us having to copy the Docker images to every single ECR.
Quite a few big Docker images, right? So we'd have to copy. Yeah.
But I mean, we could do it that way. I don't think there's a challenge on that.
If you have more questions, I think the best way is to talk to Ollie and Allan afterwards. You'll be there for?
Yeah, we're around.
Excellent.
So yeah, very happy to talk later.
Thanks very much again.
Thank you.
Thank you.